Hey again, class. This is Professor Rourke once again. I wanted to make a video regarding 2.6 number 10. So 2.6 is all about different types of limits as x goes to infinity or to negative infinity. And then number 10 is a doozy because it also brings back in squeeze theorem. So it doesn't even say that on here that it's going to use squeeze theorem, right? It just says find the limit. If the limit is infinite, enter either infinity or negative infinity as appropriate. If the limit does not exist, enter DNE. Okay, and then let's take a look at how maybe we would want no to maybe try squeeze theorem, because if we are just focusing on the limit as x approaches infinity of something like cosine x, like if it was just that piece alone, that does not exist. That is a non-existent limit because cosine, oscillates. It's periodic, right? Between -1 and 1, and it's never going to flatten out. It's also never really going to go up to positive infinity. It's not going to go down to negative infinity. It just doesn't exist. Okay, we cannot do this. So that is the piece that sort of pops out, because then it also says has another component of e to the -6x. So whenever now if this was a test question or something along those lines, I would prompt you to like, hey, try squeeze theorem, but that's sort of the giveaway, is that we could maybe try this using squeeze theorem because this is a trig function, sine or cosine, and then we have like another factor, or typically you're multiplying by something else. Okay, so this reminds me a little bit of one of the questions on checkpoint 1, where some of us had the main idea, but it is important for a lot of this section to like make sure you're not missing anything. A lot of this unit is just about like being able to correctly express your thinking, and it does unfortunately require specific documentation of that thinking. Okay, so for instance, first things first is we know that cosine is essentially trapped or squeezed between -1 and 1. That is the range of cosine. So you need to make sure you have at least that part down. Okay. This other part, I don't typically take off if it's not here. But if we think about something like e to the -6x, okay, e to the -6x as x goes to infinity, let's think about what that would kind of look like, right? Let's go ahead and do this here. Okay, so e to the x, right? We talked a little bit in my last video. If you didn't get a chance to, you definitely want to watch that. Is a function, right, that it starts out at a horizontal asymptote on the left at 0 and then increases without bound to the right. But negative e to the -x, you can think about this a couple different ways. It's really just like a reflection of that e to the x graph. So it's going to sort of reverse there. The horizontal asymptote is going to be on the right-hand side, and then it's going to increase to the left. The main idea, though, all we need to say for right now, we'll come back and deal with that whole thing in a second. But for right now, we do want to just throw out there that e to the -6x is greater than or equal to 0 for all x. And then you can even, like, if you want to be real fancy, I saw a question about like, what does this r with this special r look like? And that's just saying x is in the set of all real numbers. So it's just saying x, this function is always greater than or equal to 0. That's helpful because if we're going to multiply each side by e to the -6x in this inequality, we don't have to worry about possibly like flipping the sign of the inequality. Because if we multiply by like a negative number, we would possibly have to flip the inequality, but e to the -6x is always positive, so we don't have to worry about that. Okay, so that's just a little side note that I won't take off if you don't see that, but I do need to see that cosine, that cosine is between -1 and 1, because that's what this is all built off of. Okay, and then for all the squeeze theorem, really, like, we try to make it match what the original question based off of where we're beginning. So we begin with cosines between -1 and 1, and then we try to make it match what we have. We need e to the -6x, so I can multiply every side of my inequality by e to the -6x. So we'll say negative e to the -6x is less than or equal to e to the -6x cosine x, which is less than or equal to e to the -6x. Okay, and then the whole reason we did that was so that we could then introduce this limit component. Okay, so then we'll say, all right, slap of the limit on there. The limit as x goes to infinity of negative e to negative 6x is less than or equal to the limit as x goes to infinity of e to the negative 6x times cosine x, which is less than or equal to the limit as x goes to infinity of e to the negative 6x, which I know is a lot going on there. Okay, so from here, what we're going to go ahead and do is see if we could possibly evaluate the outsides, and we can, even if it might not feel like it. The limit as x goes to infinity of negative e to the negative 6x. So there's a few ways you can do this. If we want to kind of go off to the side and just focus over here, like a little side nib, there's a few different ways you could think about this. I'm going to walk you through essentially using like a u substitution. Okay, to try to make this a little bit easier. Sometimes this really helps with when we have these complicated limits at infinity. Okay, so instead of thinking about what is happening as x goes to infinity of negative e to the negative 6x, like that's a lot, right? So instead, we're just going to say like, okay, this is like essentially a composition of functions. I'm going to go ahead and say u equals negative 6x. Okay, again, this is just a way to sort of take a function that's more complicated and break it up into more manageable pieces. So what the benefit of that is can just focus on instead, let me back up real quick. It's in our, whatever we're finding is going to be more simple. Okay, so what we do first is we're going to take a look and see if u equals negative 6x, what is the limit of u? Limit as u is going to infinity. Okay, as x is going to infinity. So we'll say the limit of u is the limit as x goes to infinity of negative 6x. Okay, and if we think about it this way, negative 6x, right, that's just like a negative function. It's going to be going down to negative infinity. Or you could think about it like if essentially it's like negative 6 times like a negative infinity, even though we can't really do math with negative infinity, it's like negative 6 times a number that's going to negative infinity. Negative 6 times a number that's going to infinity is going to be negative infinity. Whew. So that was a lot of infinity talk there. Okay, so long story short, this is what we can do if this sort of like these functions are just kind of overwhelming. We can be like, okay, well, you know what, let's just take a piece at a time. Let me focus on the exponent here, and then we can say that like u is going to negative infinity, and then we'll talk about like negative e to the u, and e to the u or e to the x or any problem. Remember, again, that's that graph. They love to talk about this graph quite often. Just focusing on the basic e to the x graph. As you go to negative infinity, it's approaching 0. As you go to positive infinity, it's increasing forever. Okay, so for this particular problem, if using u substitution and I just focus on like where's the exponent going, the exponent's going to negative infinity. So I can say, all right, what's the limit as u goes to negative infinity of negative e to the u? And that is just going to be going to 0. Okay, so this section is particularly challenging about like how much do you have to show, right? So if you, for this, like within the squeeze theorem problem, if you maybe didn't feel like you had to think through that far, I understand. But also you'll never be penalized for showing your thinking in terms of like a u substitution. I recommend it, again, especially if there's any kind of composition of functions going on involving e or involving arctangent, anything like that. I think it can often make things a little bit easier. Okay, so long story short, both sides of our inequality here are going to 0. And so therefore, using the squeeze theorem, the limit of as x goes to infinity of e to the negative 6x times cosine x is 0, which, isn't shocking if you've done some of these squeeze theorem problems. So I hope that was helpful. Again, I know squeeze theorem can be particularly challenging, and it doesn't even say squeeze theorem in the instructions, but the cosine part there as one of the factors is sort of the key there. And remember, again, you always want to first set up the inequality about regarding like cosine or sine is trapped between -1 or 1. And then you want to move through that to sort of like make it match the original function that we're trying to find the limit of, then include the limits, and then find the limits of both sides, which we should hopefully in theory be able to do. Sometimes it can be hard. So for this one, I just went ahead and showed you like an example, another example of how you could think about that with U substitution. I hope this was helpful, but keep me posted. I know 2.6 can just be challenging because there's some big ideas and it's hard to know sometimes what to show. Okay, thanks class.